energy transformations. I can describe energy transformations. Your starter. Describe the energy of plane W and X. Copy and fill in the blanks. The two planes have the same energy but different gravitational blank energies. So the two planes have the same kinetic energy, energy of motion. They're both moving because they're both in the air. So they have the same kinetic energy, but they have different gravitational potential energies because plane W is above plane X. So it has a greater gravitational potential energy of 50 meters because the higher above the ground, the greater gravitational potential energy you have. Describe the energy transformations these energy sources have in common. So we have a candle, a flashlight, and a glow stick. What type of energy transformations do they have? First, let's start off with, what do they give? They give a light, right? But where's that light coming from? Okay, it's coming from some type of chemical energy, correct? So what we have here is chemical energy that's stored in the candle and the batteries in the flashlight and the liquid in the glow stick. That would be our chemical energies. And then they're eventually transformed into light energy. Let's look at the example of the toaster, the light bulb, and the iron. These objects need to be plugged into an outlet, right? So their energy is electrical energy because we plug them into the electrical socket. So we have electrical energy being transformed into thermal energy, heat. They give off heat, okay? So we have, once again, electrical energy being transformed into heat. Let's look at a car, an MP3 player, and a boy skateboarding. Here we have chemical energy in the gas of the car, a battery in the MP3 player, and food that's stored in the boy's energy. This chemical energy is then being transformed into thermal energy, into mechanical energy, energy of motion. The gas in the car, which is chemical, allows the car to go, which is mechanical. Here, the battery is chemical energy being transferred into mechanical energy of motion. Again, the boy's food gets transformed into mechanical energy, energy of motion. It helps him move. So energy transformation in a flashlight is frequently described as chemical energy in the battery being transformed into light energy. The flashlight's energy transformation occurs by transforming chemical energy into electrical, then into light. Let's go over some of the forms of energy that there are. We first start off with our two types of energy. We have kinetic energy, which is energy of motion, anything moving. And then we have potential energy, which is a stored energy. So I'm just going to go right down here. We're going to look at mechanical energy. Energy due to the motion of an object, okay? So this type of energy can get transformed from chemical energy. So we would have to say that that stored energy from the food allows the cyclist to ride the bike. Electrical energy, the flow of electrons. Where do we get them from? It's nuclear energy, energy that's stored in the nucleus. So we take nuclear energy and we transform it into electrical energy. Let's have a look here. Gravitational energy, energy stored in an object's height. So the higher above the ground an object is, the greater gravitational energy it has. Thermal energy is heat energy, movement of particles. Radiant energy, that's light energy from the sun. We also have elastic energy that can be stored in a spring. Sound energy is the vibrations given off from an object. All right, let's still look at some energies before we talk about those energy transformations. So electrical energy, energy in the form of electricity that's caused by flowing electrons. Examples would be a light bulb to turn on a motor, run a hairdryer. So think of anything you need to plug into the wall would be electrical energy. Chemical energy is stored in matter because of its chemical bonds. That energy is released during a chemical reaction. Some examples would be batteries have chemical energy, food, wood, coal, gas, fuel. Some examples of chemical energy, again, coal, natural gas, wood, photosynthesis, propane, which is gas, biomass, which would be leaves, branches, food, petroleum, cellular respiration, and chemical batteries. These are all examples of chemical energy. Radiant or light energy. This energy comes from the sun. It's carried by electromagnetic radiation. So we have different light waves. The visible light is what we see, sunlight. X-rays are invincible. Microwaves are invisible. And UV light is invisible. Nuclear energy, energy that's released when the nuclei of atoms are split by fission or combined fusion. So lots of energy is given off here. An example would be a nuclear power plant. It's by smashing atoms together that give off immense amount of energies. There's mechanical energy, which is the energy of motion. So anything that moves, moving cars, wind, waterfall, running. Thermal energy, think of heat, which transfers from hot objects to cold objects. Okay, so some examples would be heating food, drying clothes would be thermal energy, heat from a hairdryer, all thermal energy. So the law of conservation of energy states energy can't be created or destroyed. So what does it mean? It means that it can only change from one form to another. It's never lost. So let's look at a flashlight. It runs on batteries. The batteries have chemical energy. When the flashlight is turned on, the chemical energy is transformed into electrical energy and then into light energy. So if transform means to change, energy can be changed from one type to another. For example, as water falls over the waterfall, its gravitational potential energy is first transformed into kinetic energy. Examples of energy transformations and their uses. Pay attention. A TV changes electrical energy into sound energy and light energy. Remember, anything you plug in involves electrical energy. Then we get the sound from the TV, and then light is given off from the TV. A toaster changes electrical energy into thermal energy, which is heat energy, and light. A car changes chemical energy from the gas, from the fuel, into thermal energy, which is heat, into mechanical energy, which is motion. A flashlight changes chemical energy from the batteries into light energy. When you speak into your telephone, sound energy from your voice is changed into electrical energy. The electrical energy is then converted back into sound energy on another phone, allowing someone to hear you. Light energy is converted into electrical energy using solar panels. Campfires convert chemical energy stored in the wood into thermal energy, which is heat, which is useful for cooking food and staying warm. Nuclear energy generates a tremendous amount of thermal energy, which then can be transformed into electrical energy in a nuclear power plant. Exit questions. These are all STAR test questions. Describe the energy change that takes place from lighting a match. So here we have chemical energy stored in the match is changed into thermal energy, which is heat, and then light. This appliance dries clothes primarily by converting electrical energy into heat energy into mechanical energy. Remember, anything that you plug in is electrical, okay, and the dryer heats, it's thermal energy, and then we have movement, which would be mechanical energy. A cook heats a meal in a microwave oven. What energy transformations occur between the microwave and the meal? So what type of energy do we need for a microwave? Electrical energy, because we plug it into the wall. That electrical energy is then converted into electromagnetic energy, which then is converted into thermal energy, heat, to heat the food. Okay, so electromagnetic energy would be the microwaves that then get converted into thermal energy. The diagram below shows a hot air balloon rising. Propane gas tanks are seen at the bottom of the balloon. What energy transformations occur when the propane gas is used to lift the balloon? So propane gas, remember, a gas is chemical energy, right? And then that chemical energy is then transformed into thermal energy, which is heat, okay, because we have a flame, and then it's mechanical. Then we have energy of motion, the balloon goes up. So we have chemical, the propane gas, being converted into thermal energy, which is heat, and then mechanical energy, which is motion, and the balloon goes up. The blades of a wind turbine are at rest until the movement of the air causes the blades to spin. Which energy transformation happens when the blades are spinning as shown? So, when the blades spin, we have energy that is energy of motion, mechanical, which is being transformed to electrical.